Can everybody hear me okay? Yeah? Awesome. So, almost everybody on. But I feel like the first part of chapter 7 notes or 7.4 notes are kind of a review. Okay. Okay, so section 7.4 is basically on finding trig functions of any angle. Wow, I wrote that really wrong. Okay. So, if we start out with the local definition, or let me apologize. I'm just gonna snap everybody real quick so I can get attendance. Okay. All right. So we're gonna review a definition here, and you guys should definitely be able to get this. If we have an angle theta in standard position, A comma B, okay, for any of the coordinates except for the origin, okay? So the exception here is if it's 0, 0, okay? On the terminal side. Okay? If r equals the square root of a squared plus b squared, okay? And that would denote the distance from 0, 0 to AB, then we would have the following ratios. Okay. Okay. What do you think we're gonna have? Somebody do it with me.
Sine is b over r.
So what's our cosine gonna be?
A over r.
Okay, so then that gives us b over a for tangent. And then if we go to the flip sides, we just gotta flip everything, right? R over b, r over a, and then a over b. What is the only thing that cannot be in the denominator?
0.
Right? So this is provided that no denominator tor equals 0. Okay. If it does equal 0, then the trig function of that angle is not defined. Okay. Any questions up to this point? Because this is basically what we've been working with the past 3 lessons, right? Okay. Go away for right now. Okay. So, example 1. We want to find the exact values of the trig functions for any angle. So if we're given a positive angle, if we have 4, -3 is the point on its terminal side. So first off, all right, does everybody have this written down, and or do you need a few seconds?
I could barely see it because it looks blurry from my computer screen.
Okay.
Hmm?
If you need me to,
Yeah, mine too.
Okay, I will. Let me see if I can pull it up for you real quick. Give me 1 second, because I don't want to, came up with an idea that I think might help us too. Just give me 1 second to get it uploaded. Excellent. Okay. All right. We will just do a screen share. So just so you guys are aware, I do have this nice, lovely whiteboard, and I'm sure there will be some moment in time when you'll want me to use it again. But it's here. I just want you all aware of it. But we will switch over to the textbook. I think that'll help you guys out better. That should be a little less blurry for you, right? Does that help you out a little bit more? Okay. So just so you guys know, I'm going to go forward 1 page because unfortunately this is split up into singular pages. But if you notice down here in the bottom left, that was kind of like the general imagery that they're using there. But I'll get it back to you so you guys can write that out. All right, let me know when you are good to work with the example, and I'll scroll down. Okay. And I do apologize for not getting section 3 notes up yet. I'll probably put them up the same time I put today's notes up. But I'm going to assume, since most of you guys have been making it to class, that you are not behind on notes. Okay. So are we all good to scroll down? I can scroll down for the first example. Okay. All right. So what we're going to look at here is if we are given the point 4, -3, and if you look to the left there at figure 44, that kind of gives you an idea of what it looks like on the coordinate plane. And I will do my best later to kind of draw that out for you. So it's on the teacher notes, but for right now, we'll just reference the text. So we have to find all of our functions. Now, obviously, with it being the textbook, they've decided to go ahead and give it to you. So therefore, we can't really discuss it unless you guys have a question or you can't see where they're getting it from. Does anyone not understand where they're pulling their solutions from? So I think what I'm going to do so that we don't have silence the whole time is I'm not going to show you the problem until after we've discussed it. Okay. Do you guys have any questions on example 1 there? Okay. All right. So for example 2, we want to find the exact values of the 6 functions of a quadrantal angles. Apparently not, because those aren't matching up. I apologize. Okay, so we want to find the exact values for any angle. So we find the exact value for the 6 functions for the positive angle if -3 and 3 are on its terminal side. So basically, do it again, but now instead of the point 4, -3, what are you're working with the point -3, 3. So what are we going to do here? What's going to be different? What do you have to find first off? What's the first thing you have to find? What do you guys think you have to find?
Can you say that again?
So if we have a new problem And it's a lot like example 1, but instead of the point 4, -3, you want to find all of the trig functions for the given the point -3, 3. What's the first thing you're going to find?
The radius.
Yes, you want to find your radius. So if we have the point -3, 3, what do you think your radius is going to be?
Equals 3.
4.24.
And if we didn't want a decimal, we wanted to keep it as a radical, what would it be?
3 the square root of 2.
Good. Yep. Okay, so now that we have that, you have your R, you have your A, and you have your B. So you guys should be able to figure out your trig functions now. If you want, I can share this in the, we can do it in the whiteboard. Okay, so we're given -3, 3. We just found our radius as 3√2. Okay. So what do you guys get?
Root of 2 for sine theta. I got the root of 2 divided by 2.
Okay, so √2 Does everybody see how / agree?
Yes.
Can you explain how you got that?
So I took B, which is +3, and then I took R, which is 3 times the square root of 2, and I divided them since 3 and the 3 on the denominator are cancelled out, so you get 1 over the square root of 2, and then you need to rationalize the denominator, so you multiply by both square root of 2 in the top and in the bottom, and then you get on top you get the square root of 2, and then square root of 2 times square root of 2 equals 2, and you get that as your final answer.
Okay, thank you.
Mhm.
I think cosine is the same. Is it?
It's the same, but it's negative.
Right. There you
Yeah.
go. Mhm.
You're right.
Same rationale, just opposite sign. Very good. And when I put my teacher notes up, I'll make sure that each step is completely figured out, you know. It's just kind of hard on the whiteboard to squeeze everything in. So I'm trying to make it a little bit more readable for you. So then for tangent, we're looking for B over A.
-1.
Okay. And if we take that approach, then cotangent would be also be -1. And then what do we notice about
Oh, and then the cosecant is 3√2/3. Do you have to simplify that?
do you have a radical on the bottom?
No.
So I'm sorry, my attention was split for a moment.
It's okay.
So for cosecant, we're gonna have, let's just work that one out.
Yeah, 3√2/3.
Okay. So then we would just have √2.
Oh yeah, yeah.
Okay.
Sorry.
No, you're good. No need to apologize. I wanted to actually let you guys know I have the wonderful opportunity to actually get out of my apartment for a little bit. So I am in Sylvan of Easton, which is why I have this great whiteboard that does not fall on my head. So I'm kind of in two zones. So even though I'm focusing 100% on you guys, there happened to be somebody that floated into the little area I'm working in. So my attention got dragged. So I do apologize, but it's kind
All
of
good.
nice to be in a safe environment that's also not where you've been for the past 6 months. So, okay, if we look at secant now, secant is R over A, right? Which means it'll be the same as cosecant except what?
It's negative.
Very good. Okay, and I'm gonna save this for you guys. Okay. So if you're following along on the teacher notes or the guided notes, whatever you want to call them, the next thing we're going to look at is it's a table 4 that's in the text. I'm gonna screen share it for you with you guys, hopefully. So we're gonna pause on this screen share. I do apologize for the continuous screen sharing. It's just that with your class, it's with your course, not even your class, but with your course. Oops. Page too far. Your course just has a lot of referencing, so it's just really hard to not screen share. Okay, guys. So you want to focus on this table 4. If you don't have the printout of the notes, you definitely want to either use your snippet tool or your just handwrite it, however you want to do it. But this table here, which is it big enough for you guys? Do you want me to? I think I can. There we go. Is that a little bit better? Okay. So you're looking at table 4. And it just wants you to go through and kind of have these ones memorized. Now, let me make it abundantly clear to all of you. I don't know how the other 165 teachers are approaching this, or professors, whatever you want to call us. I guess professors. I am not someone that requires root memorization. So if knowing and memorizing all trig functions in your life is a life goal of yours, you may certainly have that life goal. I will be here to support you 100%. If you want me to send you a PDF file that has every single possible whatever I can find for you to sit there and memorize, I will do that for you. I have no problem sharing resources. That being said, I will tell you that even in class, if we had, the ability to have an in session, I allow in all of my classes for a note card on the exam. So you certainly may use your resources on the quizzes and you may use your resources on the exam. That being said, you don't truly need to sit here and memorize this, but you do need to write it down because it will probably help you on the quiz, and then you wouldn't have to, pull this up again. And you would just have it, written down in front of you. But again, I'm prefacing, you do not have to have anything memorized, at least for me. I don't need you to memorize anything. And if that is not the case, and I have misspoken because I need to eventually make you do something for the department, then I will apologize then. But as of this moment, I don't see why you need to memorize anything. I will tell you the hardest thing that I had to do in trig in high school is we had to turn in, we were given a blank unit circle and we had to fill it in from memory. That was one of our exams. It was the most terrible thing I think I've ever had to do. I was like, I just didn't understand what was the whole point of making me memorize it when then you turned around and said we could use it on all the other tests. Okay. You guys have any questions for me up to this point? Are you okay? Okay. All right. Just trying to find I don't want to give you guys answers by scrolling through the electronic text. Oh well, we'll just talk about it. So if two angles are in standard position are said to be coterminal, they have to have the same what? What do you guys think?
Terminal side.
Mm-hmm. Yep. Very good. Does anyone need to see an example of that? Because now that we have it,
Yes.
Yeah.
okay.
Can I just,
Yeah, let me get it. That's what it was, because I zoomed in so far. I didn't see. There we go. I didn't see that it was right on the next page. My apologies. Old eyes and all. Okay, so since we got the right answer there, we can go ahead and move it to the example. So if you notice here in figure 49, the terminal side is the exact same in both of these positions. Okay, so that means we have coterminal angles. That would
so angle A and then angle B are coterminal angles
Mhm.
because they use the same lines.
Yes.
So,
Yes, and if you look,
Alright.
they're giving you two different examples there. But if you drew those out, if you wanted those as examples, you can either concentrate on A or B, or one or two, however you want to look at that.
Yeah.
But those are two exact examples of what coterminal means.
Mhm. Let's say we have another line going in like the both 45 degrees in the y negative and x negative
Mhm.
position. So, and then let's make angle C from that line going, I don't know, for me it's this way.
Okay. I wish there was a way to draw on these, but I
Yeah.
guess the best thing I can do is if I give you permission to share. So I'll give you permission to share, and if you share and go into the whiteboard, why don't you draw for everybody what you are
Yeah.
seeing in your mind, so we can all discuss it.
Whiteboard. Okay. So yeah, so we have this and this, and then we had this one, it's different color, red. This one here, and then like, I don't know, doesn't really matter where this one goes. But then with this here, then, so here we have like, I guess 3 lines per se.
Mm-hmm.
Different color. And then we have this angle here. We have this this angle here. That's pretty bad. And
Sorry.
this angle here. All right. So there's 3 angles that I'm kind of showing.
Right.
Now, is this yellow one and this yellow one, could those be coterminal angles or no?
It depends on, well, I mean, Does anyone else have a statement there before I give my statement? What's anyone else feel about this? I really like what we're doing today, so this is fantastic.
Like, I guess they could be coterminal if they both finish in the same red line. Like, for example, like,
Yeah. Okay.
Right, that was my thought too. As
Mhm.
long as you have the beginning terminal, or I guess the ending terminal line being the same, then yes, they would be coterminal. But if you are drawing it from a different perspective, then they just would be angles.
Yeah. All right.
Okay,
Yeah, that's what I thought. I was just clearing it up in my mind.
excellent. Fantastic. And I am going to switch it back to only myself, but if anyone ever has something like that where you guys want to discuss something, just, start presenting it and I'll switch over to it. You guys can, this is your class. I'm here to give you the information, but you guys by all means can ask and do whatever you want to do. Okay. Any other questions with coterminal? Okay, cool. So what we're going to do is we're going to use coterminal angles to find the exact value of the trig function. So if we look at sine of 30 degrees, well, yeah. Okay, so it's here. So if we look at sine of 30 degrees, oh, sorry, I'm so sorry, not 30 degrees. I must be a little tired today. 390 degrees. What are two angles that you know of that can help you with this? How can you, what do you think you can figure out there? If you need help, kind of look at that example or statement right above our example. It says if we look here, the angles 60 and 420 are coterminal, as are the angles -40 and 320. In general, if theta is an angle measured in degrees, then theta plus 360 degrees k, where k is any integer, is coterminal. And then for radians, so if I were you guys, I would go ahead and write that off to the side somewhere. I would, oh, I can highlight apparently. That's cool. Too bad I can't apparently highlight theta. It does not let you highlight theta. All right. So those are the two things I was talking about there. Apparently you can't highlight theta or pi. So I would write that down if that is something that you think might help you. I would do theta plus 360 degrees k and theta plus 2 pi radians, of course, times k. And that just goes with terminal. So now that you've kind of read about that, how do you guys think you would approach those four things? Do you guys want the whiteboard again, or do you want the whiteboard? Okay. Okay. So let's clear this because I'm pretty sure I saved it already. Okay. All right. So I'm going to type it out just so that it can be a little bit neater. And while I'm typing this out, I want you guys to be figuring out what you think your solutions would be, how you would get to them. This is together. Okay. What do you guys think? What's going to help you?
For sine 390 degrees, you can subtract 360 to get sine of 30 degrees, and then you could get 1/2.
Okay, so you can kind of look at it in either direction. So if it helps you see it as a subtraction, you can definitely use it as a subtraction because then your k there would be a -1. The other way to kind of do that is to add, so it would look like sine of 300 or 30 degrees plus sine of 360 degrees. Okay, so then there, it's like your k is just 1, but either way, it gets you the correct value of sine of 30, which is 1/2. And I don't think there's anything invalid with the method that you just took. So, perfect job. Great. All right. So someone else, and I will tell you that drawing the figures will probably help you guys in this case. I'm not going to try to butcher the drawings on the computer screen, but I will try to butcher them on the paper for you whenever I upload it. So if that's kind of our example there, how do you think we would then do cosine of 420 degrees?
Uh, 420 minus 360.
Mm-hmm. Yeah, we can take that approach.
And that gets you cosine of 60, which is I believe it is, it's either root 3 over 2 or 1 over 2.
1/2, yeah. Mm-hmm. And again, you guys could do it this way. You can also choose to see that 60 and 360 will give you 420. So whichever way you guys can see it better is fine with me. Okay. All right, so the ones that get me a little bit more confused are obviously the ones dealing with radians, but you can always, in terms of the program, if you needed to double check, you can always switch them back to degree and find your answer and then switch it back to radian. But it's just really up to what your preference is. So tangent of 9 pi over 4. what do you guys think is the coterminal angle with 9 pi over 4? What angle do you think we would essentially want to reference there?
I think it's just pi over 4.
Perfect. Good, Julia. So then we want to do the tangent of pi over 4. Okay, and that is a 4, not to be confused with a y. Wow, it's just all kinds of gross. I guess I'll get rid of it. There we go. So the tangent of pi over 4 is just... Oh no, did I get rid of my stuff? Bollocks. Ah, that was irritating. All right, I guess you guys just get a messy 4. Okay. Okay. So what's next? What about negative 7 pi over 4? What goes with that? So it's kind of nicer with the radians because it kind of screams at you what to use, doesn't it? Okay. So again, here we're going to use pi over 4. So you'll get what?
Or 1/2.
Close. It's root 2.
Oh.
Okay.
Pi over 4 is 90 degrees or
Nope. Pi over 2 is 90 degrees. So pi over 4.
is 45.
Mhm.
Um,
Okay. And then for the last one for cosecant, again, it's kind of just how you guys see it in your heads. Essentially what you want to do is you want to get it into that. You want to basically replace the theta that they're giving you with the expression of theta plus 360 degrees times k. And if you can figure out a way to rewrite it, then you can figure out the coterminal theta. So for this one, we can rewrite it as 90 degrees plus 360 times -1. And you can see how this statement here, get a different color to emphasize, this whole statement equals -270 degrees. So then all you can focus on is the cosecant of 90 degrees, which is what?
1.
Very good. And we're going to save that. Okay, so there is a snippet that I'm probably gonna take. I'm gonna just snip it real quick right now so I don't forget, and then I will make sure to add it to these notes online. Because I don't think you guys need to waste your time writing all of this down, but I will put it in for your section notes 7.3 extra notes 1. Okay. All right. Alrighty. All right, any questions on that example? Okay, if you have questions, please ask because I am here to help, and everything will probably start building pretty heavily. So if we want to talk about signs of your trig functions, what do you think that is going to look like? Let's go ahead and clear this. Okay, so let's see if I can draw it straight. That'd be great, huh? So we have one coordinate here. We have another coordinate. Okay. Guess we'll try to use text. So if we have quadrant 1 here, what do you know about quadrant 1? Do you guys know anything about the quadrants?
X and Y are positive.
Yep. So it kind of works the same way for sine and for your trig functions in a way. So what we're gonna do is we're gonna look at your trig functions as certain pairs. So you're gonna have sine theta and cosecant theta, cosine theta and secant theta, and tangent theta and cotangent. So actually I need more lines. I need to make some more. Give me a quick second. Okay. This would be so much nicer if I could just share the... I wish I could share my notes with you, but at the same time be able to pull what I'm showing. It's very hard to do everything that I want to do. Technology needs to step up its game. All right, so all things are positive here, right? So positive, comma, positive. Oop. So here we're gonna literally write all positive. Okay. Up here,
X is negative, Y is positive.
mhm. Okay, so then that just means, maybe you guys over to the other side.
Like cosine is negative and sine is positive.
Yep. So we're gonna have sine theta. Are you guys okay if I'll just type it in. It's okay. So sine theta and cosecant theta will be positive. And then that means all others are what?
Negative.
Great. So do you need me to write it out there, or do you think you guys can handle me only writing the positives? Okay, and then we know here is the opposite of the first. So everybody is what? Or you would think everybody would be what?
Negative.
Right, but
Percent tangent and cotangent positive.
correct. Okay, so tangent and cotangent are greater than 0, so they are positive. Okay, and this is positive, negative. And what do we know about this one? It's going to be cosecant and cosine. Nope, sorry. Secant. Misspoke. And then everyone else is going to be negative. Okay? Right. Any questions on that? If you want to kind of write it a little bit differently, the other way to write it is if you have this set to be just sine and cosecant. You can just go through and do what? I'm going to write them out. I want you guys to tell me. I'm going to tell you which functions you're going to focus on, and then I want you guys to tell me what they are. If that makes sense, if I'm explaining myself correctly.
Like whether they're positive or negative.
Exactly, yep.
All right. So just for like, you just want to know for each quadrant which ones are positive, where they're positive and where they're negative.
Right. So so for sine and cosecant, they should go together. So then what would they both be in quadrant 1?
Positive.
Right. And that's all we're doing is we're just gonna fill in the
Yeah.
So if you guys have them all, I'll take them. If not, I can wait.
Oh, and then the quadrant 2 is sine is going to be positive and cosine 2.
Mhm. So positive there. And that leaves us with what for the last two?
Negative.
Very good. Okay, so that's all we're doing with those. So then as soon as you guys have the other two,
For tangent and cotangent, quadrant 1 and quadrant 3 are both negative, while the remaining quadrants are positive. I mean, backwards.
gotcha. Okay. And then for the last one, we'll have what? Okay. So cosine and secant, what are we getting there, guys?
Well, the right side is positive.
And then the left side will both be negative. Good job.
Yeah.
And then I'll go ahead and save this for you guys. Okay. That is most of our notes. We're almost done. Okay, so the next thing that I want to talk about is it says determine the signs of a trig function of an acute angle given the quadrant. So name the quadrant in which the angle theta lies if sine theta is less than 0 or cosine theta is greater than 0. So if we look at the definition, if we let theta denote an angle that lies in a quadrant, the acute angle formed by blank of theta and the blank is called the reference angle for theta seen below. What do you think goes in my blanks? What's
If sorry, if what is positive and
so if we have, so the definition is if we let theta denote an angle that lies in a quadrant,
Mhm.
the acute angle formed by the blank of theta and the blank is called the reference angle for theta. What do you think we're going to be working with? We're going to be working with obviously a side, but what side have we been working with? What's the name of it? You guys remember?
The terminal side.
terminal.
Yep. So it's the terminal side. And it's the x-axis. And the only reason why I verbally said it is because if I show you, and when I do show you, which I am, it's going to give you the answers right away. And I just wanted us to try and talk about it a little bit first. So let me pull it up. And if you guys can just stick with me a little bit extra today, we can get all of chapter or all of 7.4 done. It's okay if you have to bounce, but we're literally on the last page of notes. Okay, so right here is where we were talking about. It says let theta denote an angle that lies in a quadrant. The acute angle formed by the terminal side of theta and the x-axis is called a reference angle. And if you look at figure 57, you can see A, B, C, and D are all reference angles. Okay, so we're going to use the definition of a reference angle to answer the remaining, like, I think we have 3 questions, maybe 4. Okay, so if we want to find sine of 150 degrees, what do you think we can use as a reference angle?
Uh, 150 minus 1, 360. Would that be it?
I would look more at what are you missing from 150 to get to 180? That's what I would look at.
Oh,
So what angle is going to go with you?
oh, 30.
Okay, so that's literally all they want there is what,
Yeah.
of course it's on the next page. Okay, so here we go. For solution A, they literally, that's all they need is 30 degrees. And of course I will be drawing these answers out for you. I'm not gonna try to draw them now. So, and then for part B, it says, if we refer to figure 59, the reference angle for negative 45 is just 45. You guys know what that is, okay? It just happens to be that it's in the negative direction, but you're still gonna have the same answers, okay? So example 7 says, let me get you to it. Where are we at? Okay. Given the cosine is negative 2/3, so that falls, and that theta is between pi over 2 and pi, find the exact value of the remaining trig functions. So what quadrant, first off, are we looking at? quadrant do you guys think we're looking at? If that's what we're given. What do you guys think? If you're given cosine of theta is -2/3, and you know that it falls somewhere between pi/2 and pi.
The y is positive, x is negative.
So we're looking at quadrant 2?
Yeah.
Good. Okay. If you guys want, I think I already put up a unit circle, but if I didn't, remind me, I'll put up another one. So if we have cosine is -2/3, what's sine going to be?
It'll be 1/2.
Yeah, that would be what's going on with. Okay, let's look through this. So the angle theta lies in quadrant 2. So sine theta and cosecant theta are positive, and the other 4 functions are negative. So we have to look at the reference angle. So if that's the case, then we're looking at alpha. So then the cosine of alpha is 2/3. And then we have to use that to find the remaining trig functions. So what's the first thing we have to find? If our reference angle is theta, and we have a cosine of alpha to be 2/3, what do you think you have to find? Well, right now you only have 2 out of your 3 options, right? So you got to find your missing one. So what do you got to do? They have to find what their opposite side is, right? So take a look at figure 67, because that's what you would have to do. You have to draw that out and figure out what was missing. How'd they figure that out? They used what?
You made
Yeah.
a triangle.
Yeah, they made their triangle. They used Pythagorean theorem, however you want to state it. So they had to find their missing piece, basically. So that would be √5. Okay. If you guys want, we can pick up on this question next time. But I might just put it up online for you. I'll probably just put it up online for you. And if you guys have any questions, does anyone have any questions? Okay. So I think I was nice and I opened some things up for people if they needed a little bit more time. If you need more time on something, please email me and I will open it up. The main goal is that we have to make sure we try to cover everything. Obviously before the end of the semester. So we just have to kind of work together and make sure that we can get through everything and that no one is hopefully no one will feel super, super stressed. If you owe me anything, if you owe me a quiz and it's closed, just email me. I'll open it back up. I'm sorry, you guys haven't even gotten to quizzes. Never mind. You can ignore me on that one. Let me know if you guys think you might need quizzes. I'm not really sure if we have any built in. But if you think the homework's fine, that's fine. If you would rather have, I guess, quizzes instead of just your major exams, let me know that, and I will just have Pearson. I'll make up the quizzes in Pearson. Exams, I'm pretty sure, are paper exams, and I'm not making you guys use the lockdown browser, so you don't have to worry about that. Does anyone have any questions? Okay, I will put up my work for today, and for 7.3, I'll try to get it all done today. If I don't, it'll definitely be up before Wednesday. Wednesday, we're gonna go ahead and work on 7.5. And I guess we will do, we'll probably try to have a chapter 7. Basically, I'll call it like a mini exam. Because I don't want you guys to get bogged down or worried. So, any questions for me though? Okay, I will see all of you then on Wednesday. And in the meantime, if you need anything, just email me.